Good morning, everyone. Am I audible? Am I audible, students?
Yes, ma'am.
Okay. Okay. So, last class we have discussed about the vertical structures of atmosphere. So today we will learn about the general atmospheric circulation. Okay. So general atmospheric circulation is that the movement of air. So the wind that is moving. So it has it follows some certain pattern. Okay, so how this wind moves, so it is said to be your generic or general atmospheric circulation. Okay, so basically the atmosphere, it is considered as a fluid. Okay, it is considered as a turbulent fluid, and that is this fluid, it is subjected to some very strong this thermal influence are coming, or it is affecting this turbulent fluid. And also this fluid, it is rotating over the whole this earth. Okay, so our earth is spherical in shape, so this atmosphere, which is considered to be a turbulent fluid, so it is it is subjected to some very this thermal this solar radiation also, you can say, or thermal influence, you can say. And also it is moving over the whole spherical earth. And this fluid, and this turbulent fluid, it is highly it is compressible in nature, and also it is very highly turbulent also. And till now there are no you can say there is no specific, or there is no specific technique, you can say, or experimental technique, you can say, that it has been found out for the study of this like the fluid that is circulating, or it is rotating over the whole earth. So there is no specific techniques, or this have till now exist to study about this fluid that is in the motion. Okay, so yet there are different discussions going on for this general, how the circulation is this is following how the circulation, atmospheric circulation, is going on. And one person who is known as Rossby. So this Rossby, he have given one concept of your general circulation or general atmospheric circulation. So this one, it comes under your, that he gave the study for your thermal circulation on a non-rotating earth. So suppose if the earth is non-rotating, it's not rotating, so how this thermal circulation it is been how it is happening. Okay, so this thermal circulation, so from the name thermal, so it is means that it is originating from a source which is your sun. So from the sun, this thermal circulation, it's been originating, and this is this sun, it is said to be the main source of your origin. So what happens is that your from the sun, or from the source of this origin, that is sun, about like 40% of the this energy from the sun, it is reflected to the clouds. Okay, to the upper surface of the clouds. And what happens to the rest 60% of this energy, or the rest 60% of the thermal energy, it goes for the earth absorbs all the 60%, or with some, there are some losses also while this absorbing, the earth is absorbing the thermal energy. Okay, or the radiant energy. So this while this the earth is absorbing the 60% of its losses, or 60% of the radiant energy. So what happens is that this increases the heat of the this earth's atmosphere. Okay, so the earth atmosphere, the surface of the earth is now being heated for this region. So if you know the at the equator of the earth, so more solar energy it is, it goes to the equator of the earth. And what happens, the equator, at the equator zone of the equator, the air, it gets heated up and it rises. Okay, and it rises to the, towards the poles, towards the poles of the earth. So you have to and because of this, that we have to balance the both the poles. So what happens, the in the lower layers of the earth, the air, it is, moving towards the equator. Okay, so the air in the lower layers, it is moving towards the equator, and in that way the it is the both the poles, these are managed, or these are balanced. Okay, so but what happens in the, for the actual circulation when it is happening, so these are both different. The actual circulation is different because, they are following to, there are two factors that has to be followed. So number one factor is that it is the earth's rotation, and the second one is the disturbance of the oceans and the continents. So what happens in the effect of this earth's rotation on this circulation. So how, when the earth is rotating, so how it is affected, how it affects the circulation or the atmospheric circulation is that, if a parcel of air, you can say. So parcel of air, it means that, the air which is, it is having, it is a having the temperature of the air, or the moisture, the characteristics that it is having, the air is having, it is different with the surrounding air, or it is different with the environmental air. So that is known as a parcel of air. So this parcel of air that is at, at rest, so it has to be, this it moves with a, constant velocity. And this air that is, relative to the earth's surface, it moves with a constant velocity in the orbit, and that is around the polar axis. So what happens is that if this parcel, it is, parcel of air, or if this amount of air, it is forced towards the, in the northward, in the northward direction, or in the northern hemisphere. So at a end there, it is at a constant, elevation, at a constant height. So what happens is that the radius of the orbit, it will get reduced. So from the, from there is a principle of this angular momentum is there. So from the principle of angular momentum, it is, said that the eastward velocity, the velocity that is in the eastward direction of the earth, it increases. So what happens is that the air that is rising at the equator, and it is like moving north, it, what it does, it acquires the, the whole eastward component because of the rotation of this earth. And while this by this time, while the earth is rotating, so this wind that is, reaching the latitude of 30 degree, you can say. So when it reaches the 30-degree latitude, so what happens, the these losses, it has, sufficient losses, and it tends to, it tends to lower, it subsides. Okay, so this subsiding air, it again, it divides these two, there are two branches, it divides the air into two branches, that is, one is moving towards the south, and the other part, or the second part, it is continuing in the north, or north and the eastward direction. Okay, so this is like the effect of the earth's rotation on the circulation. Then comes your the there is another factor, that is, the distribution of the land and water distribution on the circulation. So how the, the distribution of this land and sea, it is, causing the high and low pressure belts to this breakup. So it is again, these are circulation, it is affected by some certain factors, like you can say there are mixing properties of water and land. Then again there are existence of, a barrier to this airflow, or you can say that is the resistance of by this earth surface. Then comes your reflectivity of water surface and land. Then the next one is your lower specific heat of the soil. Okay, so all these four factors, these are affecting the effect of the land and the water distribution on the circulation. So this basically this circulation of air, it is these are just explained on a simple concept of how the air or the circulation is happening in the whole of the earth surface. Okay, so next we come to the weather system. We have a weather system, okay, and there are the different you have to know some terms and terminologies and the processes that are that are related to this weather system. So there are many like weather systems are there. So number one is your front. So what is a front? Front is when there is a hot air, or you can say there is a warm air, and it has to, and there is a cold air mass also. So both this, when this warm air mass and this cold air mass, they will meet. So what will happen? They will not, they will not simple mix. Okay, they will just not mix, and there will be a discontinuity between them, since one is a warm air and the other one is a cold air mass. So they, instead of they goes for simple mixing, so what will happen? There will be be a surface discontinuity between them, and that will appear between them. And this discontinuity which is appearing on the surface of this cold air and the warm air mass, so that is known as your front. Okay, and this cold air, these are actually these are heavy than your warm air. Okay, and this, the if the cold air, it is suppose it is going towards the warm air. Okay, the what will happen, the edge or the leading edge of this cold air, it is, it will be a vertical in slope. It is this shape of this cold front, it will be a vertical in slope. And if the vice versa, that is your warm air, it is going towards the cold air, so what will happen, the leading edge, it will be a warm front, and it will be having a flat slope. Okay, so this is about the front. Then comes your cyclone. So what is a cyclone? Cyclone is, formed in a very in a zone where there is a very low pressure, and it is, it is in a circular area. Okay, the wind, it will, flow towards the in a circular area in a very anti-clockwise direction. Okay, and then it will go to a clockwise in the southern hemisphere. So it will go anti-clockwise in the northern hemisphere and clockwise in the southern hemisphere. Okay, and also this cyclone, it is generally accompanied by what? It is accompanied by cloud precipitation, and that is your rainfall. Okay, and sometimes with some very destructive wind. Okay, violent wind. So this is about your cyclone. Then comes your anticyclone. So anticyclone, it is this cyclone and anticyclone are both the opposite to each other. So cyclone, it is formed in the low pressure zone, and anticyclone, it is found in the high pressure zone. And here the wind flowing spirally outward in clockwise direction. Okay, it is the, here the in anticyclone, the wind is, flowing outward. It is flowing spirally, and it is flowing outward in the clockwise direction in northern hemisphere and anti-clockwise in the southern hemisphere. Okay, and here also the anticyclone, it is accompanied by a very moderate wind and fair weather. So not like cyclone. So cyclone, it is accompanied by a very destructive wind and a cloud precipitation. So in anticyclone, it is accompanied by a very moderate and your fair weather. Okay, so both cyclone and anticyclone are opposite to each other. Then comes your tropical cyclone or tropical cyclone. It is also known as your hurricane or typhoon. Okay, hurricane or typhoon. So this tropical cyclone or hurricane or typhoon, it is formed at a very low altitude. Okay, it is formed at a very low altitude, and in a tropical region. Basically you will found this kind of tropical cyclone, that is hurricane or typhoon, in a very tropical region. And this tropical cyclone, it is accompanied by a very heavy rainfall. Okay, in whichever area this tropical cyclone is happening, so it will be accompanied by a very heavy rainfall. And this tropical cyclone, it is originating from open sea. So from sea, the tropical cyclone is originating at 5 degree to 10 degree latitude, and moves with a speed of 10 to 30 kilometer per hour to higher latitude. So basically, this tropical cyclone, it is originating from the open sea. And what is the latitude? Latitude is 5 to 10 degree latitude, and it moves with a speed of, what is the speed of the wind? It is your 10 to 30 kilometer per hour. Okay, and so this is about your tropical cyclone. Then this tropical cyclone, we know this hurricane or this typhoon, it causes very high damage to life, or to this any property. So it causes a very heavy damage. So next is your extratropical cyclone. So what is extratropical cyclone? So it is the cyclone formed on location outside the tropical zone. So whatever cyclone is happening outside the tropical zone, so that is your known as your extratropical cyclone. Okay, and this extratropical cyclone, it is possessing a strong anti-clockwise and anti-clockwise wind circulation in the northern hemisphere. So in the northern part of the hemisphere, so this extratropical cyclone, it is having a very strong anti-clockwise wind circulation. So here the wind circulation, it is anti-clockwise in nature in the northern hemisphere. And here in this extratropical cyclone, the the wind velocity, or the magnitude of the, or the intensity of the velocity and the precipitation, it is very low. And then it is happening in the tropical cyclone. So extratropical, it is little bit low, the magnitude of velocity and the precipitation a bit low than the tropical cyclone, but the duration and the area that is covered are higher. That is the time up to which this extratropical cyclone is happening. So the duration is more, and also the area that it causes, or the area covered, is also high than in case of your extratropical cyclone. So next is your tornado. Okay, next is a tornado. So tornado, under certain conditions, activity at front may develop into strong localized convection currents. So it is said here that when front is happening, so the some of the activities at front, what happens is that uh, it can it may develop into some strong currents. So these, while the front is being developed into the some strong convection currents, or from this circulation system, it is known as your tornadoes. So these tornadoes are basically, or these are usually of very small diameter. Okay, and their diameter is less than 1.5 kilometer, and their peak wind speeds may be several hundred kilometer per hour, and transitional velocity may go up to 100 kilometer per hour. That means here the wind speed, okay, the peak wind speed, that is the top wind speed, it may be very several hundreds of kilometers of, it is very, that is that much of speed it is happening. And it also has a these tornadoes, these are very destructive, and the span of their life, it is also very small, and it can just be measured in some minutes. Okay, then next is your convective weather. So convective weather, it includes all these like showers is happening, then thunderstorms are there. So all these like the drift and down drift of air, so all these things comes under your convective weather. Then last is your monsoon. So monsoon, we all know that monsoons are all these the wind systems which, and there are annual oscillation of the flowing from the ocean, and this in summers, and in reverse direction in the winter. So this monsoon seasons are, these are seasonal. So during summer we have the continent is warm, and the water in the ocean, okay, the ocean water is also warm, and the wind, it flows from the ocean to the continent, and this monsoon, it carries water to the continent to have, these are having some heavy rain and on land in summer. And also in the winter time, what is happening is that, the water in this ocean, it is warmer and than on this land. Okay, so the cold wind, it is the wind that is cold, it is it blows to the ocean from the land. And also the winter monsoon wind, it is also almost dry, and also, that is why very less amount of rainfall it is occurring in the winter season. So that is about your this monsoon. Okay, so these all these are the some of the, this wind weather system. So all these terminologies you have to know um, based on the weather system. Okay, so up to here today we will do. So next class we will go to the next topic. Okay, so you give your attendance in the WhatsApp group after this class. Okay, okay, so you may leave the meeting.